All right, Alex, you ready? You're still muted.
Is he doing Mac or PC as well?
He's on Mac.
If he's not ready, I can do Mac. I haven't installed mine either.
All right, go ahead.
Okay.
All right. Yours is installed.
It is?
You see where you type node-v right there.
Yeah. Oh, it says v16.15.0.
That's your node version. So
Oh,
you now
okay.
have the package called Node installed. Node is a runtime environment. And what that means is it takes your JavaScript code and it will compile it for runtime, which allows you to actually run it on a server, as well as other things, running as a script, executables, whole bunch of cool little things. But essentially, Node allows you to run all your JavaScript files and see something visually on a browser, as well as other places that I do not recall. So
it's like most programming languages except C and Python, if it's a Unix based system, we'll need like some kind of a runtime and RE, like runtime environment. And pretty much all that does is like take the programming language and then puts it in a way that the computer can understand it.
Perfect. Does that make sense, everyone? Turns it to zeros and ones, specifically for JavaScript. That's what Node is going to do.
I have a question real quick. When I downloaded it through that primary link that you sent that from that page in the beginning where you had PC download.
Mm-hmm.
So you did mention that downloading it that might do something differently. I wasn't sure if I was supposed to download it like that. That's why it popped up. I didn't download it through Visual Studio Code. I downloaded it through that the option of the hyperlink.
Yeah, that's no problem. Like I said, there might become issues later down the line. I'm not sure. There might be. The way how code works, code is very finicky. The reason why code is so finicky is because the way how I set up my computer, the way how you set up your computer, the way how Rob set up his computer, it gets very customized to our personal usage, especially with developers who know how to customize their computers. So there's these standards or just like methods that we use to like kind of make it consistent for everyone. And that's kind of like the way we get around having to figure out specifically why your shit is breaking. So in the future, if there's an issue with your node, you might have to uninstall it and reinstall it just so that we can get past the issue, or you might never ever face an issue with node. I'm not really certain because I did not develop Homebrew, nor did I develop Mac operating system. All I know is that this thing will most definitely install, manage, update, keep it good.
If I ever have to reinstall it, it won't affect the program anyway in terms of like the work I've done already, right? It'll automatically have whatever I have installed, even if it's preset to the program it was or whatever I was working on before. Okay, cool.
Yeah.
Like if anything, VS Code lets you kind of like switch which one you're using. So, but that's a whole process in itself. So
we'll be talking about version managers and all that jazz much later. All right, good to see that you have Node installed. Everyone else, is everyone able to type node-v into their command and get that to work?
Yes.
Is this for like, even if you have Mac? I kind of had to step away for a second and missed some things, so I don't think mine's installed. But I got the Homebrew thing.
Share your screen so that way we can work through yours specifically. Danny, you've been quiet. BJ, you've been quiet. John, I'm assuming you already got your shit set up. Angelica, you said you're home now.
Yeah, I was
We can see
waiting.
your
Yeah, I'm home now. I just downloaded the 2 programs.
Yeah, I'm waiting. It says homebrew 3.4.9. So
Oh, Alex, we can see your messages. You're gonna want to put that down.
Yeah, don't incriminate me.
Oh, this ain't
All right.
nothing serious. That's why I wasn't even thinking about it. Appreciate it.
All right, so you see how you have brew installed, right? But you have node not installed. So if you go back to the document, right there, scroll down. You did the brew -v. The next step is assuming that homebrew. Read with me. Don't move it too much because I want you to go back to your terminal. So I don't want you to make it hard to switch in between. But yeah, let's read together, y'all. This is what being a developer is, reading. Assuming that, well, actually, I will start at the top. If Homebrew is installed on your Mac, you should see its version. For example, Homebrew 2.3.0. If not, you can install Homebrew with the following command. We saw the Homebrew version, so we know we're good. On to the next sentence. Assuming that Homebrew is already installed, type brew update, brew install node. So if you go and hover over these code stuff that's here, go to the right of it. I thought that was a copy. Yeah. There we go. You don't really need to do the brew updates automatically. So just copy the next line right there, unless it copied both. Oh, okay, copy both. All right, then just paste that whole thing in. Yep. All right, so now it pasted both of those lines of code. Already up to date. Yeah, your brew's already up to date because you just downloaded it. Now it's installing node. So this is the brew install command is how brew is commanded to install packages, third-party packages onto your Mac operating system. This is how we're going to be downloading majority of the things, other than like something specific to JavaScript, but like majority of things you download to your operating system is going to be through brew if you are on a Mac.
I got an error.
What's your error?
I got the following directories are not writable by your user.
Well, what did you run? What do you try to run?
Just copying and paste what was there.
Well, you shouldn't be doing that. There's nothing for you to copy and paste. You're already at the step of node-v.
Oh, I'm sorry. Okay, that's what it was. Okay. Well, no, it says assuming Homebrew's already installed, right? Wasn't I supposed to do that or no?
You did install Homebrew, but you already installed Node outside of Homebrew, so you have
Node.
Node.
Oh, so I'm already good to go. Okay, sorry.
No problem. The only way for us to understand is by making mistakes and really understanding for ourselves, to be honest. So again, like it doesn't matter how many times I say something. If y'all do not conceptually understand it for yourself, this was a waste of time. So however much it takes for us to struggle through this, I am willing and ready. And I'm ready to take it slow as necessary, because I want y'all to really deeply understand what we're doing. All right, cool. Your node is almost done downloading. Everybody else, everybody got node downloaded? Are we all good there?
Mine's is still installing.
Hey, that's fine. As long as we're all on like the installation process of Node, that way when it's all done, we can confidently say we're on the next step. All right, Alex, you're done sharing your screen. I'm gonna stop you there. I'm gonna share my screen, and we're gonna go through a little background knowledge on computers, Node, IDEs. We're gonna read a little bit. All right. All right, so how many people here knows how the internet works? And don't read what I just wrote in the search bar. How many people in here understand? Come on, speak up.
I don't understand at all.
Anybody has a hint, an idea?
I understand what Web 2, Web 1, and Web 3 is, but how the internet works within it. Well, internet aren't there servers that you can connect to via the internet, and depending on your server is what you have access to, right? Because only a certain percentage of individuals own the internet.
Okay, okay. I like where we're going. I'm gonna take it a step simpler. All right. The first thing is that internet is developed off of phone cable lines, that type of technology, literally linking someone physically to something else. We are all physically linked. Get out of here. Anyway, we are all physically linked. I want a big image by cables in the sea. So these cables are all underwater, physically linking all of our servers together. These are laid out by companies that are Western owned majorly. One thing you might notice is they kind of choose where these lines of connection are made and how people are able to communicate through them. Internet service providers, that's a word you might know of. ISPs, Verizon, AT&T, I don't know, Comcast. Internet service providers, they are also invested in this process of laying cable through the ocean and making sure it connects. Hey, Georgia homeowner. Oops, I don't really care about that. Making sure it connects all across and then connects into a server. The server is just a computer, same thing as your Mac.
We also use satellites now.
Man, don't talk about the future. We also have
trash,
huh?
Space trash.
Oh yeah. Space pollution. So we have those wires all connected into big old computers that we call servers that literally just run the processing system to deliver one thing from another line to another, literally just carrying all these big old messengers. That messenger computer all serves through those cables and deliver into satellites, deliver into them little towers, what people call 5G towers, that's making our main brains melt or whatever the hell, and into your actual computer device, into Wi-Fi, into the cloud, which is just interconnected systems of processing wirelessly. So all these things are how we essentially deliver technology to clients. This is your digital platform. Your digital platform is cables in the ocean. That's number one threat is sharks that really like to bite on them because they think it's fun. And then all those connected servers running together to create either a wireless connection to those cables or a wired connection like Ethernet or whatever. Does that make sense? I'm gonna assume that's a yes. If we take that even a next step further, we see client server model. So this gets into the real developer aspect of it, where we're gonna have databases. So databases is literally tables that store information, and that's I want to say the core of backend development. I might be wrong, so I'm not really a backend developer. I'm more full stack. I dabble in backend, but I'm gonna say that's the core of backend development, where you're mostly handling tables, databases, and how fast your server can take that database tables information and deliver it to clients in the form of a website.
This whole thing is a module, right? The whole thing itself. The whole.
What do you mean by module?
Isn't a module like? Isn't it like a module serves a purpose, doesn't it? Like it's like it's designed to do something, like
yes,
with machine learning and face recognition, right? Is this whole? I'm trying to learn. I know like a very little bit, but I'm trying to just learn as much as possible. Are you explaining what the module does right now, or what the module is composed of?
So module is a term that's like really generic, which is why I asked, what do you mean by module?
Oh, okay.
Module, as you said, module realistically, it means like something that captures like one specific aspect of something, like it's really like, that's why when we say, oh, we want to get modular, we're literally saying like we're trying to get really specific to capture or do this one specific thing. So a module in itself is any set of things to do one thing. I don't know a better way to explain it, but like that's kind of like what a module is, which could be anything. Literally anything could be a module. If I'm doing a lesson, like this whole thing, right, that we're doing right here, the tech course is a module. Why? Because it's a lesson with a whole bunch of moving parts designed to do one exact thing, which is teach y'all how to code. So modules, too loose of a term. What I would say, I would use the term that's being listed right here. This is the client server model. This is a visual model of how it looks for a server to deliver information to a client. Now, the immediate question should be like, what's a client and what's a server? We literally went through what servers were when we talked about the internet, when we talked about how the cables and the internet all line up to create a line of communication in between servers who are literally just there running computers, forever running computers that are processing the information and passing it along to other computers, to other servers, whether it's wirelessly through Wi-Fi, through the cloud, or whether it's through a wired connection like Ethernet cables or however else you might connect, landline cable, or I don't know what else people call it, phone cable or whatever. But yeah, like, so the server in itself is a computer that's just running to deliver the messages between those lines of internet cable back to the server. I mean, back to a client. The client is you and I. A client is anybody who is going to be utilizing the digital platform, who's going to be communicating to the computer. So me now and you guys and all of us, we're all going to be looking at a computer screen and we're on a website. This website is taking data. So this website is this image. The website would just be a computer. Any of these screens would be the website. And its job is going to go request some information from a server. There's two types of servers in this model. There's the general purpose servers, which do the communication that I'm talking about, where it just takes whatever you present it and will deliver it to the database server. The database server will then store it in a table. And then from there, that table will then get requested to once again when the client asks for something. So let me give you a visual example of that.
Can I ask a question? Because I want to like make sure. I mean, yeah. I get the gist of it, but I want to like make sure. So, like just like you said, where the clients are me and you. So
anybody requesting on a computer or interface.
Yeah. So also that would, I like to tie everything into it. Like that would be like our consoles. Like my PS5 has to be a client as well because it's hooked up to an Ethernet cable or Wi-Fi or whatever. When we go on certain games, they have a certain server for themselves, correct? So it's like,
the
same thing.
Perfect. Games are a great example. So if I want to play Elden Ring right now, for me to even log in, as soon as I boot up my PS4, for example, the PS4 will be the client here. As soon as I boot up my PS4, or PS5, if I got the bread for that, it will. Let me not lie. Anyway, if I boot up my PS5, it's gonna try and log into the servers for Elden Ring, and the servers for Elden Ring are gonna get a request. Once that request comes in from my PS5, it hits the server for Elden Ring. The server from Elden Ring will go to a database. I want to get back to this one. So this is the server for Elden Ring. The server for Elden Ring will be like, hey, we got a request. This boy, Sage, is saying that I want to use this game. Do we have somebody in our database, in our backend tables, that has the name Sage, has the gender boy, and has access to Elden Ring? This is all just general examples. The database will say, hey, I found somebody that looks like Sage, looks like boy, and is allowed to play Elden Ring. And then that database will then return that information back to the general server, whose only job is to just deliver messages back and forth between client server, deliver across internet cable lines under the water, in the sea, back and forth to people. And when that gets delivered back as a response, the client now will say, hey, we found you. Because we found you, you have the right and access to go and play Elden Ring. So here's another image of it. So me, I'm on my client. I request to go to some website. The website request hits the www browser. The browser hits the web server. The web server says you are allowed to, after it checks its database table. That's the one part that's not included in here. The server will ask the database table. If I could draw something on this, I would draw. I hate when that happens. I just wanted it bigger. But yeah, if I could draw something on it, I would draw another line from the web server and point to a little table, and it would take some information, send that information to the table. The table will return the information back to the web server. The web server will then respond as HTTP response to the browser and give me whatever I need to see. So visually, what does that look like in practice? Here is the network tab on the Chrome developer tools. So anybody who learns to develop will, on the front end, will learn about the Chrome developer tools. And with the Chrome developer tools, it allows us to see things like a terminal, where I have access to something called Node, but this ain't the same Node. Don't have access to Brew or any of those things on this terminal. But what I do have access to is whatever is on this page, which is like JavaScript, things compiled onto JavaScript. And these are going to be the data objects that you're going to soon be learning about and learning what's on them. .map or something like that. But anyway, stuff like that is available on the Chrome developer tool. Super useful tool that you're going to get super familiar with. But the most important part right here is for us to see what is happening here. So this network tab is showing you exactly what's happening when your page loads. So I'm going to refresh. Actually, I'm going to clear this out first. I'm going to refresh and show y'all all the things that just happened on our computer. So the computer just made all of these requests. And as you can see, the status of these are mostly 200s. 200 means success. That means that the computer sent these requests to the server responded with a 200, you're good to go, and then it returned. We can even see in this, we have response headers and request headers. So the request and the response that we got from it. The headers that we use to make a request and the headers that we got back in the response from the computer. And look, even if you want to preview what the computer sent back, this is literally what the computer sent back. what we are displaying on the page. And this is the the real HTML, not the preview, but this is the HTML that the computer sent back that makes up the page. So does that make sense? Do you guys kind of visually see what's happening here in terms of requests being made from the server and being delivered to us, the client, on our devices? Yes, no, maybe so. The class is ending soon. When this link ends, I'm done for the day. It's past 8 o'clock. So please speak up.
I think most of us are just responding in the chat, bro.
Oh, I cannot see that. Thank you for letting me know. How do I get back to the chat? Oh, I'm an idiot. I saw 7 messages. Hey, ironically enough, we read. How you do that? All right. Good. Any questions about software engineering? What does it mean now that we understand servers, requests, internet, and what we're going to be doing? Do y'all understand what we're going to be doing? What element we're going to be doing when we develop? I'm going to assume no. So, like I said, there's the back end and then there's the front end. So the back end is handling the database, how the database responds to servers. The front end is handling how clients make requests to the servers. That's going to be me making sure that my code is idiot proof. And what do we mean by idiot proof? I mean, like, if somebody is on my website and I make a search bar, I have to make my search bar so robust that someone will not break it by adding random letters to the search bar, by adding capital letters to the search bar. It's not going to break my search. It has to be able to deliver information intelligently. So the work that we're going to be doing is going to be creating websites, at least from what we're learning on my end, is going to be the JavaScript that is being delivered on the page, along with the HTML that's being delivered on the page and the CSS that's being delivered on the page. So the homework I want y'all to do is learn what HTML, CSS, JavaScript is. When we come back, I want y'all to explain how these 3 things interact. And also, if you can look up some JavaScript data structures, the string, the array, and the object, and a few others, honestly.
You said array, function, string, number, object, map.
Perfect.
Are you going to be putting this stuff in the Google Doc for us, like the homework? Cool.
Yes. All right. This is going to close soon, so I'm going to say goodbye to all of y'all. Appreciate y'all for coming through. Next week, I'm going to have Twitch set up so that way we could have an open learning session. And yeah, thank you all for being a part.
Thank you for having us, bro. Thank you for doing this.
Thank you.